تنحني له فيها رجال تحبها
يا خليص يا خليص
واحنا معاها كلنا الغلاها جينا نغني في حبها
يا خليص يا خليص
اخلص جنة ما تنحني له فيها رجال تحبها
يا خليص يا خليص
واحنا معاها كلنا الغلاها جينا نغني في حبها هنا أصبح المجد هنا عاد يسدو بالغنى صوت وغنى لنا
يا الله يحفظك يا خليص
وكلنا نحتفل بكلنا يا غلانا وأمنا جعلك لعمرك هنا.
السلام عليكم ورحمة الله وبركاته. أولا كم نحن سعداء أن نكون هذا اليوم بين أهلنا في خليص. إن شاء الله بإذن الله سبحانه وتعالى هذه جزء من استمرار مشاركة جامعة الملك عبدالله للعلوم والتقنية في التنمية والتطوير في المملكة العربية السعودية. جامعة الملك عبدالله هي جزء من المحيط في منطقة مكة المكرمة وفي المملكة العربية السعودية، بالإضافة إلى دورها المشهود له على مستوى العالم. اليوم بروفيسور مارك تيستر هو أحد المتخصصين القلائل الموجودين في العالم في مجال الزراعة في المناطق شحيحة المياه والمناطق الجافة. له أبحاث متعددة سواء داخل جامعة الملك عبدالله أو خارج الجامعة. بروفيسور مارك لديه بكالوريوس في علوم النبات من جامعة كامبريدج عام 88، بالإضافة إلى الدكتوراه من جامعة كامبريدج عام 88. حصل على درجة البكالوريوس من جامعة إدلد عام 84. اهتماماته البحثية في الآليات الجزيئية التي تمكن بعض النباتات في التربة ذات الظروف الصعبة، بالإضافة كذلك الزراعة في المناطق أو في المياه العسرة. ما حافظ وقتكم كثير، أتمنى لكم حديثا شيقا مع بروفيسور مارك. بعد نهاية الحديث سيفتح المجال لبعض الأسئلة إن شاء الله بإذن الله سبحانه وتعالى، وشكرا لكم.
Thank you, shukran. Thank you very much. It's an honour to be invited to be part of this first festival, and I'd just like to thank the organisers very much for inviting me, and thank you all very much for coming along to listen. I'll try to give a short introduction to Kaost and some of the work that we're trying to do there. And then we'll close with an example of a company that we're spinning out. That is how we're trying to now give back into the local economy from some of our research that we're doing at Kaost, which is of course what is expected, and it's what's needed, and it's certainly what we all want to do here in Kaost and in the kingdom.
السلام عليكم ورحمة الله. أرحب بكم وأشكركم لحضوركم هذه المحاضرة، راجيا أن تعود بالنفع عليكم. سوف أتحدث عن موضوع الزراعة في المناطق شحيحة المياه. سوف أضرب مثلا بالشركة التي اعتزل إنشاؤها، وسيكون حديثا تفاعليا راجيا التوفيق.
So, Kaost is the neighbour to the north of here. It's, as you all know, a new university which is dedicated to international excellence in scientific and technological research, and has the aim of applying that knowledge to problems of relevance to this kingdom and to the region and to the world. We have 4 research thrusts, and these are all relevant to this festival and to this region. The 4 research thrusts are food, water, energy, and environment.
كما تعلمون أن جامعة الملك عبدالله للعلوم والتكنولوجيا هي جامعة جديدة أنشأت في المنطقة المتاخمة لهذه المنطقة، وهي جامعة تسعى للتفوق في البحث العلمي والتكنولوجي، وتهدف هذه الجامعة إلى تطبيق المعرفة التي تتوفر لها من خلال الأبحاث على مشاكل المملكة والمنطقة والعالم بأسره في المجالات ذات الصلة. وتركز الجامعة على 3 مجالات بحثية هي الغذاء والماء ثم الطاقة والبيئة.
And I'm the professor of plant science at Kaost, so I lead some of the research at Kaost which is focused on food in particular. I do research on crops, but of course, especially evident in this country, no food if we don't have water, and so water is absolutely an essential part for this production in this whole region, in fact in the world. So what we're interested in particular at Kaost is the interaction between people like me who are specialists in plants and people such as, in fact, Dr. Ryan Leffers. You should perhaps stand up. Dr. Leffers is a particular round of applause for Dr. Leffers, because he, not only has he just received his PhD, but Dr. Leffers is an engineer and he specialises in particular in water. And so he and I collaborate very closely, because without one, we don't have the other. And so that really is a very strong axis, I think, of activity here in Kaost. So hence the title I had here, Crops for a Water Limited World. We certainly have a very big shortage of water here in this region, and we want to try to help grow crops in this type of tough environment.
أنا بروفيسور متخصص في علوم النبات، وأقود البحث الذي يتركز على الغذاء وخاصة المحاصيل. وكما لا يغيب عليكم في هذا البلد نجد صعوبة في توفير المياه الكافية للزراعة، وكما تعلمون أنه لا طعام بدون ماء، فالماء هو الحياة، ليس في المنطقة فحسب إنما في العالم بأسره. ونهتم في جامعة الملك عبدالله للعلوم والتقنية بين التفاعل بين المتخصصين في مجالات الصلة. فهنالك تعاون وثيق بيني وبين الدكتور ران ليفوز الذي حصل على الدكتوراه، وهو كذلك مهندس متخصص في مجال المياه، وبيني وبينه تعاون وثيق. ومن ثم عنوان هذه المحاضرة محاصيل، زراعة المحاصيل في المناطق شحيحة المياه، ونحن نسعى إلى تحقيق حلول لزراعة المحاصيل المطلوبة في هذا البلد.
So the emphasis, of course, here in Saudi Arabia is of a water limited environment. But in fact, what is amazing, an amazing fact, is that globally, of the whole world, about 1/3 of our food is produced under irrigation. 1/3 of the food that we produce over the whole world wouldn't be produced if we weren't putting water on that food. And the other amazing fact is that of all the water that us humans use on the planet, at least 2/3 of it, can be as maybe 3/4, it's between 2/3 and 3/4 of this water that we use is being used just for agriculture. And in this kingdom, the estimates are something in the order of 85% of all the water. Still, even in this kingdom, where water is so valuable, by far and away, most of it is being used in agriculture. That's shocking. It's astonishing. Thank you.
نركز هنا على الزراعة في البيئة شحيحة المياه، ومن المدهش حقا أن نعلم أنه عالميا ثلث الغذاء الذي ينتج لا بد من ضخ مياه فيه، يعني هو عن طريق الزراعة بالري. ومن المدهش كذلك أن من كل المياه المتوفرة للبشر في جميع أنحاء العالم نجد أن ثلثي هذه المياه أو في بعض التقديرات 3/4 هذه المياه تخصص للزراعة. كذلك من المدهش أنه حتى هنا في المملكة نجد أنه مع أن الماء عزيز جدا يخصص 85% من المياه للزراعة، وهذا في الحقيقة مدهش للغاية.
Could I have the next slide, please? So, we all know that a lot of the water being used in agriculture in Saudi Arabia is being extracted from the ground unsustainably. The water stores are being depleted. Now, that's not good, but this is exactly what is happening in every, without exception, every underground water supply that's being used for agriculture across the world. So here, I'll be in Pakistan in a couple of days' time, in the northern eastern corner of the country, in the famous Punjab. There's 100 million people living in that region. It's a heavily agricultural region. It's the breadbasket of South Asia, and it grows huge amounts of wheat. It is all irrigated, and most of the water for irrigation comes from underground, and that is being extracted from the red line, the aquifer that is shown in red. That is from that northwest India, northeast Pakistan region, the Punjab. And that water, sorry, not red, blue, the pale blue line, this line. The red line is us in the Middle East, but the blue line is in northern India, northern Pakistan. This cannot, that is a very big depletion, and that has also been validated. This is all measured by satellites, which can measure the gravitational pull from the water that's underground. But it's all validated by you just got to talk to the farmers. Those wells are going down and down. You talk to your farmers here locally. The water has to be extracted from deeper and deeper. This is not sustainable. We can't keep doing this. And so this really is an issue. We mustn't get depressed about it or complain about it. We have to address it and work out how to fix this particular problem. But that blue line is sustaining, something like 500 million people are being fed from that water supply that has been depleted. The wells are going down about 1 metre a year in the whole Punjab region. So this cannot go on for much longer, and that really is, I think, really a disturbing challenge. Thank you.
نعلم أن المياه تستخدم في الزراعة، ولكن هي تستخرج كثير منها تستخرج من المياه الجوفية بدون استدامة. استخدامنا للمياه الجوفية بهذه الطريقة يؤدي إلى نضوبها، وهذا ليس بالجيد، يمثل مشكلة، وهذا يحدث في كل منطقة، ليس في هذه المنطقة فحسب، إن في كل منطقة تستخدم فيها المياه الجوفية للزراعة. ففي باكستان التي زرتها قبل أيام في منطقة البنجاب على وجه التحديد. نحو 100 مليون نسمة يعيشون في منطقة زراعية كبيرة جدا تعد سلة للغذاء في منطقة جنوب آسيا، وهي تنتج القمح بكميات وافرة كبيرة وتستخدم فيها المياه الجوفية. الخط الأحمر في الخارطة هذه يبين منطقة الشرق الأوسط، والخط الأزرق يبين منطقة شمال غرب الهند وشمال غرب باكستان وشمال باكستان. وبالطريقة التي تستخدم فيها أو يستخرج فيها المياه من باكستان في هذه المنطقة يحدث قدر كبير من نضوب المياه، وهذا يقاس عن طريق الأقمار الصناعية، وكذلك يمكن التحقق من هذا النضوب والقدر الذي يحدث به من خلال الحديث مع المزارعين. يمكنكم أن تتحدثوا مع مزارعين. نلاحظ أن نصف مليار نسمة يغذون من هذه المنطقة، ونجد أن نضوب المياه يحدث بقدر متر بعمق متر سنويا، وهذه مشكلة كبيرة ولا يمكن مواصلة الاستفادة من المياه بهذا القدر. هذا لا تتحقق معه الاستدامة، ولا بد من إيجاد حل لهذه المشكلة.
Thank you. I've picked up the word estidama several times. That was one of the first words of Arabic I learned, along with sabkha, salt swamp, salt marsh. So could I have the next slide? Yes, good, right. So we have a challenge. We have a challenge which is national, regional, and in fact global. And what we need to be able to address this challenge are inventive, original, high-risk approaches. This is the job of universities. We're in the business, sure, of helping with short-term problems, but we're also in the business of doing things which business can't do, which are things like higher risk, trying higher risk solutions and seeing if we can work them through and deliver them for the nation, for the kingdom. And this is what we're trying to do at Kaost for this particular issue. And there are many, many approaches, of course, many approaches. I'm just going to describe some of the work that we're trying to do, and that is to try to see if we're able to access and use for agriculture water that we currently cannot use. At the moment, we are using fresh water. We are using liquid fresh water that we can relatively easily access. That is only about 1% of all the water that we could potentially use in the world. For every drop of fresh water, and you see this in this kingdom, for every drop of fresh water, there is at least another drop of brackish water. That's water that isn't as salty as seawater, but it's too salty for us to currently use with our current technologies, at least economically. And of course, for every drop of fresh water and brackish water, there's huge amounts of water that's very salty, that's in the sea. If only we could access some of these vast amounts of water for agriculture. That's what we're going to try to do today.
Is this worldwide?
That is worldwide, yes.
أمامنا تحدي كبير، ليس على المستوى الوطني فحسب، إنما على المستوى الإقليمي والعالمي، نحتاج لمعالجته ومواجهته، ونسعى لتحقيق ذلك من خلال مناهج ابتكارية عالية المخاطر، وهذا عمل تقوم به الجامعات، حيث أن الشركات التجارية تسعى إلى إيجاد الحلول قصيرة المدى. أما نحن في الجامعات فنأتي بحلول عالية المخاطر لا تستطيع شركات القطاع الخاص القيام بها. في كاوست نحن في جامعة الملك عبدالله نحن نفعل ذلك من خلال اتباع عدد كبير من المناهج، حيث نحاول أن نصل إلى المياه التي لا تستخدم أو لا نستطيع استخدامها الآن. فنحن الآن نستخدم الرطبة التي تمثل 1% فقط من المياه الموجودة في العالم. هنالك أنواع أخرى من المياه التي لا يمكن استخدامها إلا عن طريق تكنولوجيا متقدمة جدا، وهي المياه منخفضة الملوحة. هذه يمكن استخدامها، حيث المقابل كل نقطة ماء عذب نجد على أقل تقدير نقطة ماء منخفضة الملوحة. كما أن هنالك كميات ضخمة من المياه شديدة الملوحة التي تستخرج من البحار، ونحن نسعى لإيجاد حلول للاستفادة من هذه المياه.
Next slide. So, the aim of the work is to see if we can unlock seawater, and not just seawater, but also all of those vast amounts of water that's brackish that we cannot currently use. And we're going to try to do this to help provide food security for the kingdom and contribute to feeding the world. Next slide. So, what we want to do is see if we can unlock the potential which is currently hidden in the plants that are around us, so we can develop crops which have an enhanced ability to grow on brackish water or even partially desalinized seawater. And to do this, we need to increase the tolerance of crops to saline water, and we need to be able to improve our abilities to generate and use low quality water. Okay.
هدفنا إذن هو إطلاق مياه البحر، إطلاق استخدام مياه البحر وكل المياه قليلة الملوحة أيضا التي لا نستطيع استخدامها حاليا. وهدفنا الأساسي من وراء ذلك هو تحقيق الأمن الغذائي للمملكة العربية السعودية، ومن ثم الإسهام في تحقيق الأمن الغذائي العالمي. نحاول أيضا إطلاق القدرات التي نجدها بشكل مخفي في النباتات من حولنا لتطوير محاصيل لها قدرة معززة للنمو من خلال استخدام مياه قليلة أو شديدة الملوحة. ولتحقيق ذلك لا بد من زيادة تحمل النباتات للملوحة وتحسين قدراتنا في الاستفادة من هذه.
So we want to unlock the potential that we see is out there. We want to unlock seawater and brackish water for agriculture. If we're going to do all this unlocking, we need a key. And we need to have serious innovation. That's the core job of universities, innovation. And so, the key for all of this, and this is a really, really big key, which is new technology, which is called genomics. So you might have heard of personalized medicine. So you're able now, each of us can have our genome sequenced, the information can be analyzed, and so when we get a type of diabetes, it was just in the newspaper a couple of days ago, they say there isn't one type of adult onset diabetes, there are 4 different types. And each of those different types can be identified using genomics, and each type of diabetes needs a completely different treatment. So this is called personalized medicine, and this is all because of this incredible ability we have now to sequence our genomes. And we can do exactly the same in agriculture. Exactly the same. We can sequence the genomes now of individual plants, and we can measure the properties of those individual plants. We can, for example, measure their ability to be able to keep growing when irrigated with brackish water. And there'll be differences between the different plants. And we can measure the differences in their growth, and we can measure the differences in their genome makeup, because we can sequence their genomes now cheaply and easily. And this provides us, just as medicine is facing a revolution right now, so too is agriculture. And this provides us with massive opportunities, and for me, great hope for the future, where I think will be able to address these big problems in a water-limited world.
إذا أمامنا إطلاق قدرات استخدام المياه المالحة سواء كانت شديدة أو خفيفة الملوحة، ولتحقيق ذلك نحتاج إلى مفتاح، وهذا المفتاح يتمثل في ابتكار جاد، وهو العمل الأساسي الذي تسعى الجامعات لتحقيقه. وهذا المفتاح لا بد أن يكون من الحجم الكبير، حيث نحتاج إلى تكنولوجيا جديدة، ولعلكم سمعتم عن تكنولوجيا الجينومات في الطب، وحيث استطاعوا من خلال قياس أو تحديد التركيب الجينومي ومن خلال تحليل المعلومات الجينومية إيجاد الكثير من العلاجات. وتحقق أيضا اكتشاف أن مرض السكر ليس نوع واحد، إنما هو 4 أنواع، وكل نوع منها يحتاج إلى علاج مختلف، وهذا ما سمي اصطلاحا شخصنة العلاج، يعني لكل شخص علاج مختلف من الآخر. هذا الحال ينطبق كذلك على النباتات وإيجاد الحلول اللازمة لاستخدام الماء المالح لنمو النباتات. فمن خلال تعرفنا على اختلاف النمو في النباتات من خلال تحليل المعلومات الجينومية، توفرت لنا ثورة مماثلة للثورة التي عرفها الطب، وهي تمثل لي أنا شخصيا فرصة كبيرة وأمل في المستقبل لإيجاد حلول لمشكلتنا التي نتحدث عنها.
Thank you. Key to appreciate, these are going to be short slides, so just a couple of short slides. So key to appreciate is that plants are very variable. Just like we are all different, so too individual plants within a species. So here are mangoes in the fruit shop at Kaost in the mosque, and there's some potatoes from a market in South America. Massive differences between the plants. You can see this with your eyes.
لا بد أن نلاحظ ونقدر أن النباتات تتسم بتنوع كبير، وهي شأنها في ذلك شأن البشر. ففي هذه الشريحة نستطيع أن نرى المانجو المعروض، ثمرة المانجو المعروضة في متجر في جامعة الملك عبدالله للعلوم والتقنية، وإلى جوارها نجد أيضا بطاطس هي مصورة من سوق في أمريكا اللاتينية. نجد اختلاف كبير جدا جدا بين الاثنين.
Okay, and plants can be really, really tough. So these are plants in Saudi Arabia out growing in extreme conditions. That's all.
النباتات يمكن أن تكون صعبة أو قاسية جدا جدا، فهذه النباتات ذات السمات الصعبة يجدها تنمو في المملكة العربية السعودية.
And plants can grow in seawater. This plant can produce quite large amounts of seed that's really quite oil rich and is growing in the Persian Gulf and can definitely grow also here in Western Saudi Arabia.
وهذه النباتات يمكن أن تنمو في البحار، وهي غنية بالحبوب التي يمكن أن ننتج منها الزيت، وهذه النباتات تنمو في الخليج العربي، وهي أيضا يمكن أن تزرع ويستفاد منها في المنطقة الغربية.
Good. And even close relatives of crops can also grow in very difficult conditions. Here are some photographs of a very close relative to tomato, which can grow on the rocks being splashed by the sea in the Galapagos Islands in the middle of the Pacific Ocean. And these plants have evolved to grow in very, very difficult conditions, much more difficult than any normal tomato ever grows, yet its genome is almost the same. as a commercial tomato. And these plants can be hybridized with commercial tomatoes. So, for me, with our research, with these new technologies, I can now ask really simple questions, such as what genes are in those plants that are being splashed by the seawater, in those tomato plants that are being splashed by the seawater, and can we then use our genomics technologies? We don't even need GM technologies. We can use genomics technologies to breed the genes, the toughness genes, from these tomatoes on the Galapagos Islands into the tomatoes that we eat.
النباتات كما قلنا متنوعة، وهي يمكن أن تكون أن تنمو في ظروف مختلفة، وإن كانت نباتات تنتمي إلى نفس العائلة النباتية. فهذه الطماطم التي تنمو في جزر غالاپاغوس هي طماطم مختلفة تماما، تعيش في ظروف أو تنمو في ظروف مختلفة تماما عن الظروف التي تنمو فيها أشكال أخرى من الطماطم، ولكنها تشترك معها في الجينومات. والسؤال البسيط الذي يدور بكل العالم: ما هي الجينات التي تطلقها مياه هذه الأبحار وتتسبب في نمو هذا الطماطم؟ من خلال عمليات تلقين أو تهجين يمكن أن نطلق هذه المنتجات من الطماطم في السوق مع منتجات الطماطم العادية المألوفة لدينا.
In fact, we've just had a PhD student graduate from our laboratory, and she was working on these tomatoes and discovered one individual with one trait, one individual it came down to, with one trait that really helps the plants hold on to their fruits when they're being irrigated with salty water, with seawater. And that plant, that individual, is now being crossed into at least a dozen different commercial lines, and that work has been done by another person who is here with me today. Could you stand up? Gabriela Fina. So Gabriela, yeah. So she's been hybridizing these tomatoes using non-GM technologies. Very, very simple. Thank you. Okay. Tomatoes are one thing. Yes, no, you do it. Yes, sorry.
هي طالبة دكتوراه، حصلت على الدكتوراه مؤخرا، عملت على هذا النوع من الطماطم، حيث اكتشفت أن نوع واحد من الجينومات يساعد هذه النباتات على الاحتفاظ بثمرتها عندما تروى بمياه شديدة الملوحة. واكتشفت أنه يمكن إحداث 12 خط تجاري باستخدام هذا النوع من الطماطم. هذه الطالبة هي كابريال إيفينا التي حجنت هذا النوع من الطماطم بدون استخدام تكنولوجيا تعديل الوراث.
Good. We're also working with the crops that provide us with our daily bread, the cereals, which really provide about 80% of the world's food to fill our stomachs. And this is one crop, one example here. This is wheat. And some varieties of wheat grow well in saline conditions and others grow poorly. And it's a very simple question. What genes are in those varieties of wheat which are helping those plants keep growing? We actually discovered the gene for that. So if you go to the next slide, we had over a series, this tells you the timeline. This took 10 years of research from when we made our first observations in the field, all the way through the laboratory, discovering the genes, and then going back into the field and delivering to the breeders a new variety of wheat. That was a 10-year path, but we did it. And what is amazing is that we managed to find the gene that was in that previous slide that was making those plants salt tolerant, and we were managed to breed that gene into commercial varieties of wheat. And then when you go out into the salty parts of the field, so here's our field, and you go to the salty parts of the field, that single gene led to a 25% increase in yield in the salty parts of the field. So that's a real result from real application of research. That's the sort of work that we're doing, or is the work that we're doing here in KAUST. Okay.
أيضا نعمل على توفير محاصيل يستخدمها في الغذاء اليومي مثل الحبوب والقمح. تبدو الإشارة إلى أن بعض أنواع القمح تتحمل تنمو في مياه مالحة، وهنالك أنواع تنمو ولكن نموها ليس جيدا. ونحن نبحث عن نوعية الجينات التي تساعد أو تمكن هذا نبات القمح من النمو في المياه شديدة الملوحة. أود أن ألفت الانتباه إلى أن احتجنا إلى بحث استغرق 10 سنوات من أول ملاحظة ميدانية إلى حتى انتقالنا إلى الزراعة الفعلية لاكتشاف الجينات المطلوبة وتهجينها واستخدام هذه الأنواع الجديدة. المدهش أن الجينات التي تمكن النبات من تحمل الملوحة أدخلت حتى أنتجنا نوعا زراعيا، وأدت تجاربنا هذه إلى زيادة 20%، وهذه نتيجة فعلية للبحث العلمي وتطبيقه على الإنتاج.
Thank you. The next slide. Okay, we'll move over that slide. It's just another example of experiments that we're doing here in the region. So the next slide. We had about 500,000 plants in that experiment. Much of our work, remember, we're trying to unlock seawater here. So to do this, we're trying to make plants more salt tolerant so then we can irrigate them with water that we currently do not use. So one type of approach has been to make our crops that we already grow more salt tolerant. Good. But another approach is to get plants that are already very salt tolerant and turn them into crops. And this is one of them. This is a crop from South America. It's called quinoa. Do any of you know quinoa yet? You can grow it in health, you can buy it in health food shops. Yep. And it's a plant which produces a grain which is very, very nutritious. It's got quite a strong taste. It's not like rice, it's got a very particular taste. And it's actually very, very good for your health. But I'm interested in it because that plant, quinoa, can grow in half seawater. And in half seawater, it can still produce maybe 2 tons per hectare, even in this region. That's impressive. And the problem with quinoa is it has barely been domesticated. It's still quite a wild plant. Okay.
إذا نسعى كما قلت إلى إطلاق استخدام مياه البحر في الزراعة، ونسعى إلى زيادة أو تعزيز تحمل النباتات للمياه المالحة، ونتبع منهجا وهو زيادة تحمل النبات للمياه المالحة، ولكن ثمة منهج آخر يكمن في تحويل النباتات التي تتحمل درجة ملوحة بالفعل إلى محاصيل. وأضرب مثلا بهذا نبات كينوا الذي ينمو في أمريكا اللاتينية، وهو ينتج حبوبا غذائية قوية المذاق ولكنها جيدة جدا للصحة وأهتم بها، وهي تنمو في منتصف مياه البحر وتنتج ثمرتها في هذا الحد. المشكلة التي تتعلق بهذا النوع من النباتات هو توطينها، لأنه ما زال ينمو في مناطق بعيدة من المناطق الحضرية الزراعية.
Okay, next slide. Thank you. So quinoa is an amazing plant because it can grow in half seawater. It's native to the mountains in South America, where there are some of the biggest salt lakes in the world. But the problem is it's still highly variable, it falls over, it's often tall, it can't be very easily machine harvested, it has many, many problems. And so what we've done at KAUST is started to build up the foundation of resources such as sequencing the genome and gathering together as many different varieties from around the world as we're able to get legally, and build up the basic genetic foundation for bringing this plant into really the 21st century, which we need here in countries like Saudi Arabia, because I think this is a potential future crop for this country. All, in inverted commas, all we have to do, besides making it short and more like make it look more like a wheat plant, is also to make it heat tolerant. Obviously very important for this environment. And that's something which we're also working on at Kaost. So that's a higher risk, longer term project, but I really think it could provide great opportunities for the kingdom and the region.
قلنا أن هذه النبتة مدهشة جدا، وهي تنمو في المناطق الجبلية في أمريكا اللاتينية التي تكثر فيها البحيرات المالحة. لكن هنالك مشاكل تواجه في زراعة أو الاستفادة من هذه النبتة، وهي أنها عالية جدا وتسقط عند الحصاد ولا يمكن حصادها بالآلة. في جامعة الملك عبدالله للعلوم والتكنولوجيا وضعنا الأسس لجمع أنواع مختلفة من هذه النبتة لوضع الأساس الجيني الذي يمكننا من أن نستفيد منها باعتبارها نبات القرن ال21 هنا في السعودية، فهي نبتة المستقبل في هذا البلد. ونسعى من خلال تجاربنا إلى تقصير طولها وجعلها تبدو وكأنها نبتة قمح وجعلها تتحمل الحرارة. هذا مشروع عالي المخاطر طويل المدى، ولكنه يمثل بارقة أمل للمنطقة وللمملكة العربية السعودية على وجه الخصوص.
Thank you. So, from our research program, we're wanting to help contribute towards, help develop a new type of agricultural system where we're going to irrigate salt-tolerant crops with brackish water and provide, hopefully, fundamental and applied scientific discoveries to develop this system for sustainably growing salt-tolerant plants using brackish water. Another very important thing we're doing along the way is training young Saudi people for the future of the kingdom. At the moment I have 5 Saudi PhD students. All of them happen to be female. So if you've got any males you can bring to me as well, that would be great. I have 5 outstandingly good, really good Saudi female PhD students. That's I think an important contribution Kaost is able to make as well. And of course, if we are able to develop this new agricultural system, that means that Saudi Arabia can also contribute to sustainable increases in food security that's both local and global. And then I'm going to finish with one more slide or a pair of slides of a local company that was spinning out.
إذا من برامج الأبحاث التي ننفذها نسعى إلى الإسهام في تطوير نظام زراعي جديد وتطوير محاصيل عالية التحمل للمياه المالحة، ونسعى كذلك إلى الوصول إلى برامج علمية تمكننا من استدامة زراعة هذه المحاصيل. وملاحظة مهمة جدا هي أننا ندرب في جامعة الملك عبدالله للعلوم والتكنولوجيا شباب سعودي. أنا شخصيا لدي 5 طالبات في الدكتوراه وهم متميزات جدا، وهذه تعد مساهمة هامة من جامعة الملك عبدالله للعلوم والتكنولوجيا. إن نجحنا في برامجنا فيمكننا أن نزيد من مساهمة المملكة في تحقيق الاستدامة العالمية من الغذاء.
Thank you. Next slide. So, what we're really doing, and we've realized that the economic sense is starting to come together even with a saltwater based system for some crops and some systems. So what we're going to do is establish a company and just do it. And we're going to do it here, in this region, and we're going to build and operate a seawater greenhouse where we are able to replace as much as 90%, potentially even 95% of the irrigation water is going to be of the water used in the greenhouse. 90 to 95% of the water used in the greenhouse will be seawater, not fresh water. And we're doing this by replacing 100% of the fresh water used for cooling the greenhouse with seawater. And we're going to, for the irrigation of the plants, tomatoes are already quite salt tolerant, and we can, in fact, not just irrigate the tomato plants with diluted seawater and get a yield that is unaffected or minimally affected, we can also improve the quality of the tomatoes, because one of the responses of the tomatoes to be irrigated with this seawater is that they increase their sweetness. So we're going to make a tomato that is not only going to have a massively smaller ecological footprint by using seawater in the greenhouse. So about 90% of the water in the greenhouse will be seawater. We're going to provide a product which is going to be higher quality. Furthermore, with all of that salt water in the system, the plants are actually healthier. There are fewer pests and pathogens because the pests and pathogens are affected negatively by the salt water. So we think we have a system, a seawater greenhouse, a commercial, economically viable, profit-making greenhouse that will be using 90 to 95% less fresh water than a normal greenhouse.
إذا ما نقوم به هو أن نسعى إلى تحقيق فوائد اقتصادية من خلال استخدام مياه مالحة في إنتاج المحاصيل. وما نعتزم فعله هو أن ننشئ شركة هنا في هذه المنطقة، نبني ونشغل بيوت زجاجية تستخدم فيها مياه البحر المالحة، توفر علينا 90% إلى 95% من المياه العذبة التي كانت تستخدم في مثل هذه البيوت الزجاجية. وكذلك نستبدل المياه التي تستخدم في التبريد بنسبة 100%. ولن نكتفي بأن نستفيد من هذه التكنولوجيا في أن نقلل من الأثر البيئي الضار الذي يمكن أن يحدث عن هذه الزراعة، إنما نسعى كذلك إلى تحسين جودة الطماطم الذي ننتجه ونحسن من طعمها بزيادة حلاوتها، وهي كذلك من الناحية الصحية تكون أكثر فائدة لأننا نستخدم ماء مالح. هذا مشروع تجاري ناجح اقتصاديا ومربح، ونعتزم تحقيقه ونرجو.
Okay, we're starting to explore names as well, so I'd be interested to get feedback from you. If you think that we sell in your supermarkets, in our supermarkets, tamatin tomatoes, maybe we say that these are being produced by Red Sea Farms. I don't know if this is a name that would resonate, but please give us feedback for that, please. And the last slide. Next slide, please. Okay. We have established, and we've done the economic sums on this, we have seawater technology. We already have growing in our greenhouses already seawater tomatoes with plants and fruits that are thriving and doing very well. And all we're really needing now is some investment for scale up. So we could start with a 1 hectare greenhouse and then maybe scale up to 5 or 10 hectares and then make a contribution towards the Jeddah horticultural market, a real contribution. And we'll be using our Kaust research and the Kaust know-how to start to spin out and feed back into the Saudi Arabian economy, something at least towards the food security with less water demands. So thank you very much. Okay, do you want to just do that and then?
إذا أيضا في ختام هذه المحاضرة نرجو منكم موافاتنا بآرائكم وتعليقاتكم. نحن نسعى إلى بيع هذه الطماطم في أسواقكم ونقترح نريد أن نعرف إذا كانت ستباع هذه الطماطم في متاجركم. نحن أنشأنا بالفعل تكنولوجيا تستخدم مياه البحر المالحة، وأنشأنا بالفعل البيوت الزجاجية التي تستخدم فيها مياه البحر المالحة، وأنتجنا بالفعل طماطم وثمار ناجحة. ما نحتاجه هو استثمار لتصعيد هذا المشروع وتوسيع نطاقه حتى نصل إلى حجم أكبر، ونسعى إلى فتح سوق له في جدة نستخدم الأبحاث التي تجريها جامعة الملك عبدالله والمعرفة المتوفرة للجامعة، ونسعى في الختام لتعزيز اقتصاد المملكة العربية السعودية من خلال المساهمة في تحقيق الأمن الغذائي. وشكرا.
And thank you all very much. شكرا. And thank you.
شكرا لكم على إصغائكم. ما أدري إذا في أسئلة متخصصة أو أحد يبغى يوجه أي أسئلة للبروفيسور مارك.
First of all, we thank Professor Mark, our sister, for this lecture and the scientific lecture. At the same time, as soon as we are going, we understand that we can grow tomato from the sea water, and the trial have been done for tomato. Is there a chance with the same principle, with the same water, to produce another crop, another different crop?
Using the same tomato, using the same water
same
we've
water.
just used with the
Same
tomatoes.
environment, yes.
Yeah. We certainly can do that, and would be able to reuse the water. One of the classic possibilities is, in fact, to integrate. This has been done for thousands of years. Integrate the growth of plants with that of fish or other plants, crabs, or so there, you could integrate it with meat production as well, or you could even irrigate a forage crop outdoors adjacent to the greenhouse, and then you could use that for feeding sheep or cattle. So there are definitely ways of developing systems where you can keep integrating and using the water till that water's really done. Yeah.
May I, Dr. Professor Mark, thank you very much for a very informative presentations. My name is Qasim al-Sheikh. I'm an ex-Kaust Advisory Industrial Board for 7 years. I only missed this year, by the way.
I recognize your face.
It's just because we don't have any more money for being a board there, It cost us $100,000, by the way, to be a board in there. But forget about it. My question is the following. Have you did any kind of scouting study or preliminary feasibility study of the economics of such a proposal? And if so, have you thought where it's going to be built? It needs to be near the sea. And in Saudi Arabia, it's forbidden to have any land on the sea unless the rules are changed. The other question I have, as I said, being an ex-advisory board, you usually come to the advisory board and share such findings. And have you did it this year, last year, 2 years ago, and what was the results?
Yes, I did come to the advisory board and presented about 1 or 2 years ago. And your face is familiar. I think we've met up at Kaust in the past, yes.
The last question I have,
But
if I
anyway,
may.
well, okay, go on.
I want you to answer all of them.
Yes.
The last question is that there is a Saudi scientist. His name is Dr. Ibrahim Al-Alim, who has a lot of researches since 20 years ago on this particular field, where he developed a kind of products from many research centers in Europe, and try to bring it where with a little bit of such fertilizers you could grow a lot of area. Did he come to Kaost and share with you some of that, or somebody else could lit or give some shed or lit some light shed lights on that?
Sure,
please?
sure. I would very much appreciate if you could introduce me to Dr. Ibrahim by email or give me his telephone number, and that would be, I'd very much like to look into that.
I will.
Thank you. And to go back to your first question, have we scouted and got land? Yes, you said we need seawater. Seawater is the best because that's a massive volume and it's very, very easy to get. But if we're just a couple of kilometres inland, we just have to drill a little hole. That doesn't cost much money, and there's lots of land that sits over brackish water, and that water can often be 3/4 seawater, or even more concentrated in some cases than seawater. We can use that water. So we will be inland, just a little bit away from the edge of the sea, and we will drill down and use the water that's just immediately underground. Okay, so we have got land we've got land for a 1 hectare site, the greenhouse. We don't have land for a 5 or 10 hectare greenhouse. We haven't scoped that yet. So again, that would be something which would be a valuable contribution. We can put a 1 hectare pilot facility, which is still a pretty big pilot facility. We can put that on Kaost land yet. Well, we have done it for our seawater tomato company, and we get a return on investment in less than 4 years using several different models. It's a robust economic model that we've developed. So I think that business will work for seawater tomatoes. We're talking about other companies like maybe for the seawater irrigation of forage for sheep and cattle. I mean, we think that does stack up with the sums. The economic viability does seem to be good, but we're not as confident of those calculations because we're much further advanced, if you like, with our knowledge and our experiments for the seawater tomato system. Go out into broadacre crops, I think we'd still need more research, and I don't think we have an economically viable model yet for relatively low value crops such as wheat or even quinoa, not yet.
Yeah, because as you know, the problem is now, is this competing with the normal product produced? That's the thing.
Sure. Now it depends on the tomato. If we really want to get into the details just for a few seconds, if you've got a high value tomato for eating, it's been purchased in a supermarket here in Saudi Arabia, the sums add up. We've got a viable business, we're confident. If it's for a processing tomato, all right, to make tomato ketchup or something like that, I'm not so sure. Ryan might like to comment a little bit on this because I think there's a possibility that it might be viable for a processing tomato, but it's a little more marginal there. And there are more risks with processing tomatoes because you get more pests and diseases coming in because it's an open system.
Are you charging the investor for providing him with the technology?
Oh, well, we'd have to discuss that. With the investor might want equity, they might want their money back with a lot of interest. There's various, as you know, there are many business models for financing our company, and at this stage, we're pretty flexible.
That's very great. Thank you very much.
Thank you very much.
نتمنى من الأستاذ يترجم لنا المحاضرة ببعض الأسئلة والإجابات حتى يفهم باقي الجمهور. هل يترجم الآن أم نكمل المناقشة؟ ما أدري إيش رأيكم. طيب ماشي.
Professor Tester, thank you for a wonderful presentation about a wonderful research program, and it's very promising research program. We really appreciate it. I have a very quick question, if you would. How old is your research program? How old is it? 1 year, 2 years?
Yeah. My research at Kaost started, I moved to Kaost 5 years ago, 5 years and 1 month ago. So my research program is 5 years old. I've been working with tomatoes for 5 years. But of course my knowledge and my program builds on what I brought with me from my previous 2 positions, which were, one was in Australia and then before that I was in Cambridge. So I'm like a lot of these things, you build on your knowledge, and you learn from your mistakes.
Are you aware of any similar research programs in Saudi Arabia? Are you aware of anything like this?
No, there isn't. In Saudi Arabia, I do work with 2 other major researchers in universities, so KAU and KSU, here in Jeddah and over in Riyadh. And in Riyadh, there's a wheat breeder, Professor Abdullah Al-Dos, and some of his colleagues I've been working with since I arrived. They're very welcoming and very friendly. Here at KAU, we've got a fantastic, a really, really good collaborator, a gentleman called Magdi Musa, Dr. Magdi Musa, and he is a tomato horticulturalist. And so we've been doing a lot of our experiments in the field using the KAU field station. So we have an intensive collaboration with KAU.
But worldwide, there is I think there is a similar research programs, not in Saudi Arabia.
Yes, there are definitely similarities. I think what's slightly different about our work to other work anywhere, actually, is that we're studying these salinity tolerance mechanisms at a very, very genetic level, using this new genetics, using this genomics, where we're able to sequence whole genomes. That's pretty new.
Okay, my last question. I would like you to explain the statistics you gave in your presentation about the percentage of water used in agriculture in Saudi Arabia. It is 85%. Worldwide, it is 67%.
About, yeah.
Why? Could you just give us just a quick explanation?
Well, a lot of the world produces a lot of food. Oh no, sorry. Why is it 67% of the water being used? Yeah, that's actually a good question. When I said water, that's fresh water being used. So, and when we look in Saudi Arabia, with your primary industry of oil extraction, that doesn't use very much fresh water. It uses a lot of brackish or salty water. So I think here you have really only 2 major users of your water, your agriculture and households in cities. So that's it. Whereas in a lot of other countries, there's a lot of other industries which use fresh water. I suspect that's why there's a lower percentage of freshwater usage in other countries, because there's a bigger industrial sector that uses fresh water.
نعتذر من بقية الأخوان لتكريم وضبط الفقرات، سامحونا. شكرا لكم، شكرا دكتور مارك. سعادة المحافظ، هناك تكريم من هناك فقرة أيضا تكريم بعد تكريم الدكتور، ثم الأمسي.
Thank you very much. That's fantastic. It's a beautiful castle.
Yeah, I hope we will see it, inshallah.
Yes.
It's very useful for us, and we would like to inquire from university and from you, especially what you do, what you do, your research. We hope in the future we will make something good for our محافظة.
Good. Thank you very much. Thank you. شكرا.
أبواب الجامعة ونفتح قلوبنا قبل كل شيء للمجتمع. إن شاء الله بإذن الله سبحانه وتعالى الاستمرار حيكون التعاون مستمر. تواجدنا إن شاء الله بإذن الله سبحانه وتعالى حيكون مستمر في كل المحافظات وفي خليص. يعني أنتم جيراننا وأنتم أهلنا كذلك، فمرحبا بكم المتخصصين
معانا واحد قامة نسعد بها والله يحييك بأهلك وأهلك الله يرضى عليك الله يحفظك.
دكتور عبد الغني.
بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وسلم تسليما كثيرا. حياكم الله في أمسية جديدة ومتجددة في مهرجان خليص الزراعي الثقافي الترفيهي. نقول ثقافي لأن ما شاء الله الآن سمعنا محاضرة قيمة ويليها أيضا أمسية شعرية، ليالي متجددة وما زالت في زخم ابتدائها بفضل الله سبحانه وتعالى ثم جهود وقيادة محافظنا المحبوب الدكتور فيصل الحازمي. نستأذن الحقيقة سعادة المحافظ لجنة التنمية الاجتماعية الأهلية في إحياء شرق خليص كانت لها مشاركة في جناحنا في المهرجان، وأيضا من باب مشاركة أكثر طرحت مسابقة على شقين، مسابقة عن طريق حسابها في تويتر وأخرى في المهرجان بشكل مباشر. تسحب لي كل يوم جمعة 4 جوائز، جائزتين للنساء وأخرى جائزتين أيضا للرجال. اللجنة الحقيقة حاولت يعني تستغل هذه الفرصة وتكرم بعض الشخصيات اللي كان لها جهد مع اللجنة في إبراز برامجها وتفعيل الكثير من برامجها، والإعلام لا يخفى عليكم أهميته ودوره. شخصية إعلامية كان لها دور يعني مهم في مشاركة اللجنة، مشاركة فعالة. وهذه الشخصية الإعلامية من ضمن يعني هيئة تحرير صحيفة خليص الإلكترونية، أيضا ترأست الصحيفة لفترة معينة، عقدت معها اللجنة شراكة، والحقيقة رأت اللجنة أن من حقها أن تكرم هذه الشخصية، وهو الأستاذ رائد حامد البلادي. التكريم الثاني الحقيقة لشخصية ولإحدى بناتنا طالبة في المرحلة المتوسطة، رنيم عطية شبيان البلادي. هذه الطالبة شاركت في مسابقة أولمبياد الرياضيات في المملكة العربية السعودية، حققت المستوى الأول على مستوى المحافظة، وكذلك المستوى الأول على تعليم جدة، وكذلك المستوى الثاني على مستوى المملكة العربية السعودية طلاب وطالبات. تستحق التكريم ويستلم تكريمها نيابة عنها اللي هو والدها عطية شبيان البلادي. شكرا سعادة المحافظ، شكرا للحضور، والسلام عليكم ورحمة الله وبركاته.
بعد الصلاة إن شاء الله محاضرة الأمسية الشعرية في هذا المكان. الله يحييكم.
جنة ما تنحني له، فيها رجال تحبها
يا خليص يا خليص،
واحنا معاها كلنا الغلاها، جينا نغني في حبها.
يا خليص يا خليص،
خليص جنة ما تنحني له،